Hello student, in this video lecture we are going to see the procedure to develop a stiffness matrix. We already know, so what is mean by stiffness? Stiffness is equal to force by deflection or moment by rotation. Okay, so in the definition, the force produced by the unit displacement is called as stiffness. Force produced by the unit displacement is called as stiffness, or moment produced by unit rotation is called as stiffness. So, now we are going to see the procedures to develop that stiffness matrix. So, stiffness matrix, the properties of stiffness matrix we already know. It is a square matrix. So, it can be like this, it is a square matrix, number of rows and number of columns are same. Then the element of each and every element of this stiffness matrix is equal to the force. Okay. So, that is stiffness is equal to force by deflection. So, force produced by the unit displacement is called as stiffness. So, therefore, the element of the stiffness matrix of forces, the element Kij. So, that I represents at, then J represents due to, that is the force developed in the direction I due to unit displacement in the direction J. Okay, the force or moment developed in the direction I due to unit displacement or unit rotation. Unit displacement in the sense it includes both translation and rotation in the direction of J. So, first step. So, in order to develop the first column of stiffness matrix, give unit displacement at direction 1 only. It means all other coordinates are locked, and measure the force developed in all coordinate direction 1, 2 and up to n. So, first thing what should we do means, first we have to lock all the coordinate direction. So, that is we have to fix it. Then for developing first column of stiffness matrix, so we have to provide only a release in the form of unit displacement in the direction 1 only, coordinate direction 1 only. So, all other coordinate directions are locked. Then we have to measure the force developed in all the coordinate direction 1, 2, up to n. Then we generate the second column of matrix. So, for this, so what should we do? Give unit displacement in the coordinate direction 2 only, and all other coordinates are locked, and measure the displacement, measure the force required in all the coordinate direction 1, 2 up to n. Then this procedure is repeated up to n number of columns. Then let us see an example to understand this concept easily. So, what is the question? Develop the stiffness matrix for beam AB with the coordinates shown in figure. So, it is a cantilever beam, one end is fixed, other end is free. So, at the free end of the cantilever, they have given 3 coordinate direction. So, one is along x direction, then another one is along y direction, then third one is rotation. Okay. So, moment or rotation in the z direction. Okay. Then the length, area, Young's modulus and the moment of inertia of the beam are constant. So, what is the solution? Let us start with the solution of this problem. So, first thing, the order of the matrix. The order of the matrix is equal to number of coordinates chosen. So, in this case, in the problem they given 3 coordinate direction. Okay. So, therefore, number of coordinate chosen is equal to 3, order of the matrix equal to 3. So, our stiffness matrix is a 3 by 3 square matrix. Okay. 3 by 3 square matrix. The first step to develop first column of stiffness matrix. Give unit displacement at coordinate direction 1 only. It means all other coordinate directions are locked. So, in this problem there are 3 coordinates. So, first, in order to develop the first column of stiffness matrix, we have to provide only unit displacement along coordinate direction 1 only. So, other two direction displacements are arrested, okay, displacements are arrested, and measure the force developed or recovered in all the coordinates directions 1, 2 and 3. So, first and foremost thing is we have to log the structure, okay. So, given beam is a cantilever beam, one hand is fixed, so other hand have 3 coordinate direction. So, first coordinate represents a displacement along x direction delta x, second coordinate displacement along y direction, third one is a rotation along z direction, okay. So, first and foremost thing is we have to arrest this horizontal translation, vertical translation and rotation of joint B. So, for this we have to provide a fixed support, okay. This fixed support arrest translation along x and y direction and rotation about z, okay. Then, so to develop the first column of stiffness matrix we have to release only in that only translation in the x direction only, okay. We have to allow unit displacement along x direction only. So, at point B, so we have to allow unit displacement, that is delta x is equal to 1. So, now B moves to some other point, some B dash, okay. Some B dash. So, stiffness is equal to, so either force by deflection or moment by rotation. So, K11. So, K11 is the element of the stiffness matrix. K11 is equal to force developed in the direction 1 due to unit displacement in the direction 1. So, therefore, K11 is equal to force by deflection, force by, so where force P taken as P